Tonight is April the 28th, 2020. I hope everyone out there is doing well and staying safe. Everything's good here. What I want to look at tonight is something that was brought up by a good gentleman that I communicate with on YouTube, just like many of you. And it was about the spurs that are on the harmonics, on the fundamental and the harmonics. Let's look at this one right here. This is the output of the Tektronix SG505 oscillator. Very, very pure. 0.001% it says. And this is pretty accurate. It doesn't absolutely agree with the Tektronix and the Hewlett-Packard, as they don't absolutely agree with each other. The Tech says it's 0.003, and the HP says it's 0.0077. In either case, it's 0.00 something, so it's very, very low, and we can trust it. There's what it looks like right there. There's the sine wave. I'm trying to keep the glare down. Turn a little bit of glare off. There we go. Okay. But what's important here, and what we're going to do tonight, is investigate the spurs. See, we don't have any spurs here. This is our fundamental, 1 kilohertz. We're not trying to measure absolute power output or anything like that. We're going to be running all the amplifiers at 15 watts. You can see a tiny bit of the third harmonic here, but you can see that's very clean. See a little bit of 60 hertz down here. I don't know how accurate this is, but it says it's below 120 dB. Probably is. It's going to be pretty darn low. I have to keep hitting run on this to keep it operating. But anyway, what we're going to do is look at 3 different amplifiers. We're going to start with this old Mac, an MC40, and then we'll look at this one, which is the a channel that I've built out of an MA230. I've shown it a number of times. And then we'll look at this one and see what we think. I'll give you a hint. This one's got more spurs on it. But let's just do one at a time. So now that we know how clean the signal is, let's take one more little gander at it here. You can see how clean it is. Now, what you're going to see in the next one is we're going to hook up this Mac amp right here. I'll have to stop and hook it up. I've also got my little watt meter out here so we can read power from this guy. Of course, we're not pumping any power into an amplifier. We're not measuring the output of any amplifier right now. We're just measuring the output with this oscillator right here, this SG505. It's supposed to be as low as 0.0008. 8 parts per million. And its output voltage right now is 5 volts. I'm just running it max, and we've got it set to kilohertz. I also want to remember to do it at 1024 hertz, because that's a multiple of 2, and might have something to do with the Nyquist frequencies display and how it is displayed on the how its harmonic profiles are displayed. Let's actually just go ahead and do that. Let's see if we can get to 1024 very accurately here. Am I going the right way? I may have to use the this one is an analog output. Yeah, I'm going to have to use a different output here for if I get exactly 1024. Let's see if we can well, no, I'll have to change that. Let's do that before we get carried away. Okay, this was just a question that was brought up about, does this multiple, does this particular multiple, is it going to do anything by, is it going to create any spurs in itself? But there it is, 1024. I can't change that decimal point floating around. That's, and here it is down here, 1024 to 1025. And we're still, and now we're looking at the output of just the the HP, and it says that its THD is 0039. It's very, very low too, very, very good. Let's see what it looks like over here. Well, no, it's got a little bit more distortion, and it looks like it's got a little bit of second harmonic. That's not a bad thing, and the purpose here is not to compare the HP and the Tektronix. That's not the objective here at all. They're both very good. The HP does have a little bit more distortion in it. A little bit more of a harmonic, although the THD is still extremely low. I'm beginning to see that the THD, there's more to it than just the THD, and I think we can actually measure it and see it quite easily here with the audio spectrum analyzer. And you see there's no spurs on it either. There's no spurs around the fundamental. Okay, now let's look at an amplifier. Okay, I've got it set up. I'm actually going to use this oscillator right here instead of the Tektronix for no particular reason. Well, I can just punch in the number. I'm actually punching in 1024 frequency 1024 hertz. It keeps coming out with 125.4. Well, maybe, I don't know. What can I say? Anyway, the voltage that we're looking at here is across 8 ohms. And here's our power. I'm running it at something low. Not exactly any particular level, but something well below what it should be. And actually, I've been generally testing them around 15 watts. So there we go. Let's set that at 15 watts. Here's a little analog meter that you can see. It looks like it's 10, 12, 14. It looks like this one says it's a little over 16. Now, again, that's not our objective here, and this is the amplifier we're testing. This one is running into this load right here. Since I have 3 amplifiers, I've got this amplifier here, and one channel of this amplifier running into this dummy load right up here. And that way I can just use that little toggle switch and flip back and forth from left to right channel. But since I've got 3 amplifiers, I need 3 dummy loads. This is exactly the same resistor except for a smaller value there. They're very low inductance. They're called non-inductive, and they're 1%. They have a temperature coefficient that I don't remember its number, but they from cold to well over boiling up to like 300 degrees, they don't change at all. Anyway, it's actually fairly warm. Just pumping a few watts into it. So we're running this guy right here at 15 watts, and here's its harmonic profile. And there's its distortion right there. It's a little bit below 0.1%. Or, yeah, a little bit below 0.09. So that's good. We're not trying to split that. Let's see what this one says. See, this one's saying about the same thing. Somewhere between 0.1, 0.09. It's giving us the same numbers. 15 watts. Okay. Now, looking at this harmonic profile, we will see that there are a number of harmonics created, artifacts created by the amplifier, by the Mac amp, even though the distortion is extremely low. THD is very low. But we don't see any spurs. Well, I actually see some very small spurs right around the 3rd harmonic sometimes. You've got to kind of stare at them for a while and watch it dance up and down and keep it running. But I don't see any spurs around the, well, I saw something trying to happen right there. I mean, we are really splitting hairs here, you know. We're chasing electrons, smashing electrons, so to speak. But that's what it looks like. So on a real high-end amplifier, vacuum tube amplifier, we've got our distortion. We've got our distortion products, and but we don't have any spurs on it. Okay, now let's look at a different amplifier. Okay, now that we've looked at the Mac here, we're going to look at this other Macintosh design. It's out of an MA230. This is a genuine Macintosh transformer ordered back in 1977 and built this for a center channel. It's built exactly to their specs, even with the ability to control individual bias on each tube and the balance, the driver balance. Rated at 30 watts. It originally ran 7591s or 7591s. I can't remember. 7951s. Oh, you know, those little bitty tubes. Those little tubes. Kind of like a 6L6. But it doesn't have the same pin out. The 79. I'm sorry, I can't think of that number. That's not important right now. But anyway, I'm running the EL34s in it. I like the EL34s. And here's what they look like running at about the same power. 16 watts, kilohertz. You will notice a little bit of difference here. Actually, this one's got a couple of spurs right here on the on 1 kilohertz. I don't see any out here. So these are two, you know, really high-end amplifiers. Let's turn out some glare here. Glare is always a problem. That's not even the one causing the glare. We'll be in the dark in a minute. There we go. But at least we can examine these things closely. Yeah, THD on this is down at 0.06 something. But we do have some spurs right here that were not on the 40-watt Mac. I don't remember the exact profile here. But the THD is down so low that nobody can complain about that and say that that's a problem. That's for sure. Okay, let's go back over here and let's see if I can put the lights back on without burning myself. So this is that amplifier, for what it's worth. Well, I'm just trying to get some baselines here. We know what the oscillator looks like. We know what the output of this one looks like. Now we know what the output of this one looks like. And both of these are flat from 20 to 20 kilohertz. Always less than 0.5% THD. So now let's look at this one. Now I love this one. I think it just sounds fabulous, but sometimes I'm not sure. I think I hear some grittiness in it, if that's the right word to use. Okay, so let me hook it up and we'll take a look at it. Okay, here's the Williamson design amplifier I've shown a number of times. Uses the Aquasound output transformers. I think it's a beautiful amplifier. It performs very nice. We'll look at both channels. Right now we're looking at the right channel, and we're putting out about 15.8 watts. And if we look at it, our THD is just ridiculously low, 0.04%. Look at all those spurs. You know what I'm beginning to think that is? I think that's intermodulation distortion. I'm wondering if it's not the mixing of the kilohertz and the 60 hertz. I'm thinking about changing it to the DC filaments like has been suggested. I mean, you can see it running. You see where the 60 hertz is down at below around a minus 110 dB according to this. But I don't know how to prove that. I can't change the 60 hertz. I wish I could. I wish I could change the frequency of the input. I wonder if I change the frequency of the output. I wonder if that would change the spurs. That might prove something. Let's try that. Okay, this is truly exciting. I have found out, I just read an article on spurs, and just kind of in passing, they related the spurs to intermodulation distortion, and that's exactly what it is. Now this is something worth recording and seeing, because look at this. Okay? See those spurs right there? See, they're pretty significant. Look at this big spur right here. This is at a kilohertz. THD 0.0405. You know, it's really low. It's not like something you'd want to work on. Let's see. Our 60 hertz is down here at minus 100 dB thereabouts. Okay, it stopped running. Now let's clip in 100 more microfarads across it. That's all I've done. Our power's the same. Didn't change our power. Now let's watch this. Oh, this is going to be good because here, let me turn on some lights. I want to get the glare off of it. Okay, now we want to see those things significantly change when I hit run, and they did. And look at our 60 hertz down here. Let's see, where's our 60? Our 60 really did go down much more. I didn't exactly notice those. Those might need to be studied, but it cleared up those spurs. Okay, take a really good look at those spurs. Like say on the that's 1, 2. Say on 2, 3, and 4. Well, anywhere in there. Okay, I'm gonna take it back off. Be careful. They can knock me on my butt. You see them now. Okay, let's see. This one is at minus 80 and minus 100 and about minus 95. Okay. Yeah, 80. No. These are at minus 90. The third harmonic is 95, and that's at 100. Okay, let's hook it back up. And let's see, let's watch those very carefully. Okay, here it goes right now. Well, the 120, it looks like this is the one that went down. Wasn't measuring it that carefully, but it really did something to those spurs. I'm going to put 100 microfarads on the other side now and see what happens. I've got to stop the camera though. Okay, now I think that pretty well cleaned up the spurs, didn't it? Well, I'd have never thunk it. Look at our THD went down to 0.02%. Just ridiculously low. I don't remember. I'll have to look at my own video here, but it seems like on the Mac amp we didn't even have this spur right here on on this one. You know, I'm beginning to think there's some filament hum in there. Maybe I'll change the filaments to DC. Okay, back at it again. Now that I've removed the two other amplifiers, this is just the one that we're working on. And I have found out some things that I cannot believe slipped my mind until now. You're going to like this. I just can't believe that I've overlooked this for so long. Let's look at the harmonic profile again. Okay. I've got it stretched out here, so we're not looking at everything between DC and white light. I think I'm looking at everything between 900 hertz and 3 kilohertz, or 900 hertz and 20 kilohertz, whatever. It doesn't even matter. That sort of matters. But I can't What I can't believe that I let slip past me for so long is measuring the distance between. Hopefully you got to be able to see all this very clearly, because this is some tedious detail. You got to measure the difference between this. Like, I'm going to use this spur right here. Well, let's use this one. Let's use this one. This harmonic. This is second harmonic, 2 kilohertz, 3 kilohertz, 4, 5. If you measure the distance between here, if you measure the frequency, if you click on that and then read it off up there, it's 1038. And then you click on this right here and you measure that one, and that's let's see, that was 2012. What is it? I read that wrong. Let's read that again. See, that's 2138 and 2012. Well, it's 120 hertz is what it is. If you look over here at the fundamental, right over here, this first little spur is 60 hertz out. This is 120. So it's 60 hertz between here and here. It's 120 hertz between here and here. So we're playing with and trying to deal with either 60 hertz line noise or 120 hertz power supply noise. So this is power supply noise right here, I'm convinced, and there's some 60 hertz. This is power supply noise in here. Okay, now the hum balance, I'm really beginning to believe that people can actually hear the difference in sound quality with a hum balance, even though it's not 60 cycle hum. You won't be hearing it as hum that we think of as 60 or 120 hertz hum, power supply noise, or line frequency hum. What you'll be hearing it as, let me show you. What I'm going to do, I got to turn some lights back on so you'll see what I'm doing. I'm just going to tilt the amplifier over on its side. I've even got the bottom on it right now, trying to mitigate all possible hum. Anyway, same tone, gotta be careful. Lean it over here. And I want you to be able to see what I'm doing. There's a hum balance right here. Okay, let's go back and look at this. This is amazing. Like I said, I can't believe it took me so long to actually get around to seeing this. Okay, let me get it running. Now, watch what happens when I tweak the hum balance. I don't know if you'll be able to look at that. Do you think you can hear that? Did you see all that rise right there? Let's get in really close to that, because I think that's really important. Look at this. The hum balance causes that. I think the really sensitive, trained musician ear can hear that, and they won't hear it as hum either. They'll hear it as probably grit. Okay, we got to make it run again. And watch this. I'm going to tweak the hum balance again. Slot. Sorry for all the fumbling. Damn. Look at there. See, I can tune all that right out. Got 'em. Except I'm left with a couple that I just can't figure out how to get rid of. That's the hum balance pot took that out. Now I know it's way down here, it's supposedly at 120, 130 dB. Well, fundamental down at 20, so you can add 20 back to that. If it says it's at 120, it's really at 100. But still, you know, it's way down, and our THD, and this is IMD, 0.02%. So, you know, a sane person would say, what are you working on? 0.02%. You know, is it just chasing gremlins and, like I said earlier, smashing electrons? Yeah, I guess it is. But I can't seem to do anything with these. I've added big capacitors. There was an idea of changing the load resistor on one so that it offsets out of phase hum. and it would actually get rid of this. This is 120 hertz. It's 120 hertz between here and here, between here and there. That second harmonic. I mean, it's ridiculously low. But I would actually like to get rid of that, and I don't know what to do. I've been stuck on this for the last couple of hours, trying darn near everything I know how. I think I've got the 60 hertz tuned out as best I can. I'm going to tweak it just a little bit more. Left and right. See, there's more. I mean, that's just so obvious. Like I say, I'm just really convinced that a super sensitive ear could hear that. Okay, now what do we do? I don't know. I want to think about it. Okay, I'm back, and look at this. They're gone, aren't they? Remember those spurs right there? Still got those over here, and I don't know why. But those are gone. You'll never guess what I did. This thing is making a believer out of me in a lot of different ways. Let me show you what I did. I changed to two 6SN7s. These are the two I've been using in there all the time. These are new ones made by Tungsol. I'm not bad-mouthing Tungsol. They're beauties, aren't they? I put in old vintage ones. I just, out of the blue, just pulled them out of the amplifier that's sitting up on top, the one that has KT88s in them. The tubes fixed it. Let's go back to that again. I'm really becoming a believer in the sound of tubes. I mean, you gotta, you know, I'm not a musician. So when THD gets down, it actually looks like the THD went up slightly. When things like this change, wow. And those tubes are probably 50, 60 years old. Now I got to fix this. I wonder if that's got something to do with the output tubes. Well, I guess that's the next thing to change. But look at that. Isn't that clean? Isn't that beautiful? I mean, that's like right out of a textbook. So the balancing, the very critical balancing of the output tube currents, which I achieved very easily by putting a 50 ohm wire wound pot between the cathodes. This is a cathode biased amplifier. It's not a fixed bias amplifier. I put a 50 ohm resistor pot, 50 ohm pot, excuse me, wire wound pot between one cathode and the other of the output tubes. And then I put the cathode resistor and capacitor combination. Capacitor is shunt with the resistor. I put that off the wiper of that 50 ohm pot to ground, and that's how I adjust the cathode currents for the lowest second order harmonic, and the THD goes down with it. And then I also, on the push-pull drivers that drive of the 6SN7, that's the second 6SN7, I put a variable pot on the plate lead of it so that I can make the drive exactly equal, and it's very critical. And that's another way I lower the THD, and I've got these phenomenally low numbers up here. And then I got rid of those 60 hertz spurs with the hum pot balance, and by just, I don't know, this is not even scientific, but I got rid of these 120 hertz. I don't know why 120 hertz spurs by changing the tubes, by changing the two 6SN7s. I don't know if it was one or both. I don't know which one it was. I just swapped them both. And the last thing is, make it run again. The last thing is, I guess maybe I can do something out there with that with the output tubes. That's just a guess. If I could clear that up, yeah, this thing would be, if I could clear that right there up, that'd be cleaner than the mic amp. Well, I guess it's time to try that, isn't it? See what happens. Okay, well, just to keep documenting it, not that I've cured what I was looking at, what I was looking for right here, but I just put in a couple of new 5881s made by Tungsol. And these two came up. Looks like the second, I don't remember. It looks like the second harmonic went down a little bit. Third came up. Looks like our THD actually rose slightly. Didn't do much over there, but it did create those two. Right there on the third. I mean, they're down there ridiculously low. They say 100, minus 130, and like I say, since our fundamentals at minus 20, that's only minus 110 dB. Only 110. But it did change it. I actually added those. Didn't do anything over here. I'm not sure what else to try now. Maybe some EL34s? Why not? Okay, I plugged the EL34s in here. That's the only thing I've changed. I can do this and get away with it, I feel, fairly safe, because I'm using cathode bias, and the bias is not going to be so outrageously different. I'd want to measure them very carefully if I was going to leave them there for a long time. But that's why I'm able to just swap this around without having to adjust bias. Well, actually I can't adjust bias unless I actually change that bias resistor, but let's see what it looks like. Now this is not any kind of a statement on an EL34 being good or bad. It did change it. Our THD went up considerably, and we ended up with spurs around both of them now, so that didn't make anything better. Actually, that went up and then it went down. I wonder why that happened. It's been warming up for quite a while. It's plenty warm. But anyway, it created some kind of big ones out there. So, again, maybe some people can hear that. I don't know. But that's probably not the best solution right there either. So, we want to leave those 6SN7s in there and go back to the KT88s, or KT66s. Since I mentioned KT88, somebody's going to ask, well, what did they do? So I had to plug them in. They warmed up for a while, and I've been looking at them. They actually haven't turned out too bad. By the way, the filament winding of this power transformer is an 8 amp filament winding, so I've got plenty of current to light these tubes. So we're not hurting anything there, and I haven't measured the current, but you know, you have to go through all this and check it out thoroughly if you want to leave it that way. But it actually didn't even turn out that bad. Let's look at them. I guess this is a form of rolling tubes here, so it isn't all bad. There's what it looks like. Let's make it run. Not quite as good as the KT66, but pretty darn close. We've got a little bit going on down in here. Not much. They've actually turned out pretty good. THD is pretty reasonable too. So with the filament winding as big as it is, with an 8 amp filament winding, I think the KT88s draw like 1.8 amps each, so it's big enough to run all 4 of them. That could be done. THD is very low. I don't think it's necessary, but they do work in this case. I'm not suggesting everybody randomly swap out their KT66s for KT88s. I'm not sure what's going to happen in your amplifier, but in this one with a cathode bias resistor, it seems to be okay. But I still don't know how to get rid of this, if I even can. Okay, let's go back to the best we've got and think about it some more. Okay, well, I think it's about time to wind this up so I can put all these videos together and post them. Hopefully there'll be some good information out here, or at least some entertainment. Let me see. I've been varying the power level. Okay, we're back at the 15 watt level, and you can see the THD levels over there, right over here. THD and IMD. I'm just paying attention to the THD. That's one on the bottom. This one down here. And I'll start running the power up, and it's kind of an interesting thing that happens. I'm gonna wait till it stops this time, so that I can start the display again, because you got to watch this real time. But what happens is, there you go. Okay, now watch this. Okay, we're running at 15 watts, 14.87. Okay, I'm going to go up to, there's 17.4, there's 19, there's 20.5. Start seeing some things creeping in there on the third. That's 21 watts, 21.7. 22.8. THD still down at 0.16, as you can see. Let's run it all the way up to about 1%. There it is, oh darn, didn't quit running. But you can see the THD now up to like 1.15, and we see all those spurs. Now, I think we're going to start to hear that. We're not clipping. I'm watching it on an oscilloscope too. Yeah, well, it's just barely starting to clip. Very symmetrical, 24.23, 24 watts. Just a hair over 24 watts. That's where it's THD reaches 1.1%. And if we run it up to heavier clipping, like right there, THD now is up to 2.9, almost 3%. But look at all those spurs in there. Now we're also clipping. I got to show you the clipping. Right there. Hopefully you can see that okay. Yeah, you can see the clipping at the top and the bottom. So if we turn it back just to where it's not clipping, which is right, about right there. The THD drops to just really low, back down to 0.1%. Let's do it right below. Okay. As you can see, the power up above it, 23.9, 24 watts, no clipping. THD is about 0.6%. And our spurs, I guess this is the spur video, maybe that's what I should call it. And that's what they look like. So I'm convinced that they're important. There you go. For what it's worth, I hope this helps, and I hope you all stay safe. And thank you for watching my videos.